welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In this episode, we'll examine security boundaries and isolation techniques. These are two of the most fundamental yet powerful methods used to contain threats, reduce risk, and preserve the integrity of secure systems. Whether you are managing cloud workloads, securing enterprise networks, or designing zero-trust environments, understanding how and where to draw clear boundaries and how to isolate components effectively is essential to building strong cybersecurity architecture. Let's start by understanding what a security boundary is. A security boundary is a logical or physical point at which access control policies, enforcement mechanisms, or trust levels change. Think of it as a fence line. It marks where one domain of trust ends and another begins. That might mean the separation between an internal network and the public internet, between a user workstation and a secure database, or between development and production environments. Security boundaries allow organizations to define where controls should be placed and what security expectations apply in each zone. Within a boundary, systems and users may share certain levels of trust or access. Once that boundary is crossed, the rules may change. For example, a firewall may control all traffic crossing from the internet into the corporate network, or an identity provider may enforce multi-factor authentication as users move from a general use zone into a high-sensitivity system. Effective boundaries are not accidental. They are explicitly planned, configured, and maintained. They rely on a combination of policy, technical controls, and administrative processes. Boundaries should reflect the value of the data and systems they protect, the potential impact of a breach, and the operational needs of the organization. Without well-defined boundaries, trust can spread too far. Systems can become overexposed, malware can move laterally without being detected, and compliance becomes difficult to maintain. Properly enforced boundaries are essential for risk containment, segmentation of duties, and regulatory alignment. Now let's explore isolation. Where boundaries draw the line between domains, isolation builds walls within them. Isolation is the practice of keeping systems, processes, or data separate, either logically or physically, so that an issue in one area does not spill over into another. Isolation techniques reduce the attack surface. They prevent unauthorized communication paths, and they limit the blast radius of a breach. If one container is compromised, isolation ensures that other containers remain unaffected. If a sandboxed application misbehaves, it cannot interfere with the host system. There are many methods of implementing isolation. Virtualization allows multiple operating systems or workloads to run on the same hardware while remaining logically separated. Containerization packages applications and their dependencies into isolated environments. Sandboxing restricts code execution to a confined area, often used for malware analysis or testing untrusted files. Network segmentation uses VLANs, firewalls, or routers to isolate groups of systems from each other. A segmented network can prevent an intruder who gains access to a printer from reaching a critical database server. Physical isolation, also known as air gapping, remains a highly secure technique for systems handling classified data where there is no electronic connection to external networks. Isolation strengthens the defense in-depth model. Even if one layer is breached, other layers continue to provide protection. This concept is especially important in shared environments like the cloud, where multiple tenants may use the same physical hardware. Without isolation, data leakage, privilege escalation, and resource abuse become real risks. Now that we understand the concepts, let's talk about how to implement effective boundaries and isolation. Start by documenting your boundary zones. Identify where policy changes occur, such as the edge of your internal network, the boundary between development and production, or the separation between third-party applications and core infrastructure. Use logical separation whenever possible. Firewalls, network access control lists, VLANs, and security groups allow you to define how systems can communicate across boundaries. Create rules that allow only necessary traffic and block everything else by default. Employ virtualization to isolate workloads. Each virtual machine should run in its own controlled environment with minimal shared dependencies. Use hypervisor-level controls to prevent inter-VM communication unless explicitly required. Adopt containerization for microservices and application workloads. Containers are lightweight, efficient, and easy to isolate. Use container security features like namespaces, control groups, and runtime policies to manage access and visibility. Sandbox untrusted applications, scripts, and documents. This allows you to test unknown content without risking your production environment. Sandboxing is particularly valuable in malware detection, secure email gateways, and secure browsing environments. Always assess and validate your controls. Run vulnerability scans and penetration tests to evaluate whether your boundaries can be bypassed or whether your isolation holds up under attack. Use simulation tools to test lateral movement scenarios and evaluate containment effectiveness. For more cyber content and books, please visit cybernet.me. You'll find best-selling books, training tools, and resources tailored specifically for cybersecurity professionals. You can also explore additional CISSP episodes and tools at baremetalcyber.com. Now let's look at specific security controls that support boundaries and isolation. Start with access control. This is your first line of defense. Use identity and access management systems to enforce role-based access, multi-factor authentication, and least privilege principles. Only users and systems that truly need access should be allowed to cross boundaries. Deploy intrusion detection and prevention systems at boundary points. These systems monitor network traffic for signs of attack or misuse and can block or alert on suspicious behavior. Placing these systems at choke points allows you to detect lateral movement and boundary probing. Secure your systems through configuration management. Harden each isolated environment with secure baselines. Disable unnecessary services. Keep software and dependencies up to date. Patch management is essential to prevent boundary crossing exploits. Use encryption for all data crossing boundaries, whether data is moving between users and servers, between cloud services, or between isolated zones. It must be encrypted in transit, using strong protocols such as transport layer security. Prepare your incident response plan to handle boundary violations. What happens if a boundary is breached? What if a container escapes its sandbox? Your plan must define how to contain the issue, investigate the cause, and restore secure operations. Include forensics and compliance reporting in your response. Let's now turn to continuous improvement. Security boundaries and isolation controls are not static. They must be updated regularly to keep pace with evolving threats and changes in your environment. Review boundary definitions as your infrastructure evolves. If you migrate to a new cloud platform, deploy a new line of business, or onboard a third-party service, you must reevaluate how your trust zones are defined and enforced. Perform incident analysis to identify where boundaries failed. If malware moved from one system to another, how did it cross the line? Were network rules too permissive? Did isolation fail at the application level? Use those lessons to refine your approach. Use audits and compliance reviews as feedback loops. If your auditors identify gaps in network segmentation or weaknesses in access control, those findings must feed into your policy updates and control designs. Collaborate across departments. Network engineers, cloud architects, security analysts, and compliance officers all have a stake in how boundaries and isolation are managed. Ensure that decisions are coordinated and based on a common understanding of organizational risk. Provide training that reflects real-world use cases. Administrators must know how to configure and monitor isolation. Developers must understand how containers are secured. Incident responders must know how to trace and contain boundary violations. Finally, take a proactive stance. Monitor for emerging threats that target boundary weaknesses, such as virtualization escape exploits or cross-ender attacks. Integrate new tools like microsegmentation, zero-trust architectures, and software-defined perimeters as your capabilities evolve. Thank you for tuning in to the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study resources, and personalized certification support. Strengthen your understanding of security boundaries and isolation techniques, and will consistently support your journey toward CISSP certification success.